Now that we have a comprehensive vision of the asynchronous messaging, let's look at some design issues we might face. One challenge is how to scale out message receivers while preserving message ordering. It's a common requirement to have multiple instances of a service in order to process messages concurrently. The challenge with processing messages this way is ensuring that each message is processed once and in order. For example, imagine that there are three instances of a service reading from the same point-to-point channel, and that a sender publishes order created, order updated, and order cancelled event messages sequentially. A naive and simplistic messaging implementation could concurrently deliver each message to a different receiver. Because of delays due to network issues, messages might be processed out of order, which would result in strange behavior. A common solution used by modern message brokers like Apache Kafka and AWS Kinesis is to use sharded or partitioned channels. There are three parts of the solution. A sharded channel consists of two or more shards, each of which behaves like a channel. The sender specifies a shard key in the message's header, which is typically an arbitrary string or sequence of bytes. The message broker uses the shard key to assign the message to a particular shard. It might, for example, select the shard by computing the hash of the shard key modulo the number of shards. The messaging broker groups together multiple instances of a receiver and treats them as the same logical receiver. Apache Kafka, for example, used the term consumer group. The message broker assigns each shard to a single receiver. It reassigns shards when receivers start up and shut down. In this example, each order event message has the order ID as its shard key. Each event for a particular order is published to the same shard, which is read by a single consumer instance. As a result, these messages are guaranteed to be processed in order.